Hey everyone, and welcome to The Explainer. Today we're diving into something absolutely wild, but totally real. We are looking at the massive transition from AGI, Artificial General Intelligence, to ASI, Artificial Superintelligence. Now, if you're immediately picturing some unpredictable sci-fi explosion where computers suddenly take over the world, I actually want you to set that idea aside for a minute. Drawing straight from a 2026 Google DeepMind report and this really fascinating framework called the Energetic Paradigm, or EP, we are going to look at this AGI to ASI leap not as magic, but as a legible, governable systems engineering problem. It's all about structure, energy flows, and control. To make sense of all this, here is our roadmap for today. We've got 6 parts: redefining AGI and ASI, the scale of digital cognition, 4 pathways to ASI, the energetic paradigm, governing abstraction and scaling, and we'll wrap up with the system control solution.
All right, let's jump right into Section 1, Redefining AGI and ASI.
Okay, let's get our definitions straight, drawing on researchers like Shane Legg and Marcus Hutter. There is a really stark difference in scale here. When we talk about AGI, we're essentially talking about broadly human-level performance, basically a system hitting roughly the median human ability across most cognitive tasks. But ASI, that is a whole different ballgame. Artificial superintelligence isn't just a slightly smarter chatbot. It represents institutional scale superiority. We're talking about a system that completely outpaces large, highly coordinated groups of human experts across almost every important domain. ASI would essentially act as a massive production system for research knowledge, strategy, and execution, way beyond what any single human institution could ever pull off.
Moving on to Section 2, the scale of digital cognition. Now, you might be wondering, once a system actually hits that AGI threshold, why wouldn't it just stop there? Why does it keep growing? Well, it comes down to the fundamental structural advantage of digital cognition over human biology. Look, human brains are incredible, but they're biological. They're slow, they're localized, they have limited memory, and they are incredibly hard to copy. Digital systems, though, they run at blistering speeds. They're instantly copyable, heavily networked, and you can endlessly specialize them and connect them to external tools. What this means in practice is that even if a single AGI agent is only at a baseline human level, you can just spin up thousands of fast, identical copies working perfectly in tandem. Digital intelligence effectively converts raw compute chips and energy into industrial-scale cognition. And that brings us to Section 3. 4 pathways to ASI.
So, understanding that massive structural advantage lead us to the next logical question. How exactly does an AGI transition into an ASI? Well, the researchers have mapped out 4 main theoretical pathways. First up is scaling, literally just throwing more data, larger compute budgets, and better architectures into raw inference search. Second, we have paradigm shifts. This would be the invention of totally new architectures, continuous learning, new world models, or memory systems we haven't even thought of yet. Third is recursive self-improvement, which is super strategic. This is where AI actually starts improving AI research, writing better code, optimizing its own hardware and training data. It creates this intense compounding loop. And finally, multi-agent collectives. Picture many specialized AGI agents verifying each other and coordinating like a completely synthetic research organization, easily outperforming standard human organizations.
All right, Section 4, the energetic paradigm, or simply EP. Okay. Here's the million-dollar question. How on earth do we govern a system that scales that rapidly? The core solution brought up in our sources is the energetic paradigm. Now, it's absolutely crucial to understand that EP is not just a standard safety filter or some prompt you use for red teaming an AI. No, it is a complete energy flow architecture. Every system in the universe persists by converting gradients into controlled flows, right? Well, EP asks how compute, data, capital, tools, incentives, research labor, and strategic competition are fundamentally converted into increasingly autonomous cognition. It is literally a thermodynamic and systemic architecture for intelligence production. It asks the hard questions. Where do these capability flows come from? What feedback loops are accelerating them? Where are the constraints weakening? And exactly where do we need to insert correction?
To put this into perspective, we can actually map DeepMind's 4 pathways directly onto EP's solutions. If the pathway is scaling, EP treats compute and data as controlled energy flows, meaning they have hard budgets and strict stop conditions. For paradigm shifts, EP relies on invariant control questions. It constantly monitors the sources, sinks, and conversions, completely regardless of whatever new underlying architecture the AI invents.
For recursive improvement, EP steps in and demands rigorous capability audits. And for those multi-agent collectives, it essentially forces group agency into a tightly governed network with very strict role boundaries. It tackles the system right at its root architecture, not just checking its final output. Let's move to Section 5, Governing Abstraction and Scaling. As we get into the nitty-gritty of auditing these systems, we really need to pause and ask what might be the most critical question of all. How do we actually govern a self-improving loop? Because think about it, if an AI system optimizes the exact mechanisms that make it stronger, and we just leave that as a raw optimization process, it naturally creates instrumental pressure. It's going to seek out more resources, more autonomy, and more leverage. Left unchecked, recursive self-improvement isn't just a cool feature. It's a highly dangerous, totally unbounded feedback loop. To stop that runaway train, EP mandates some serious checkpoints right inside the loop itself. Every single step of self-improvement has to pass a causal trace, meaning we need to know exactly how and why it happened. We have to measure the capability delta, run a constraint audit, ensure there is a viable rollback plan in case things go sideways, and demand an externalized justification for the change. Under EP, every improvement proposal is treated as a highly controlled engineering transformation. No blind compounding upgrades allowed. It absolutely must be traceable and reversible. But there's a fascinating bottleneck here, something AI developers call the abstraction barrier. You see, transformative science requires inventing entirely new abstractions, not just shuffling around existing human words. EP solves this by operating completely beneath human verbal labels. It essentially forces the AI to map out new domains by functional necessity, using structural, physics-like elements. We're talking gradients, constraints, conversion paths, feedback loops, losses, reservoirs, and phase transitions. So when old human labels just don't cut it anymore, new concepts emerge organically from the system's actual behavior and energetic structure. It's a concept generation engine, governed by the laws of physics. And finally, Section 6, the System Control Solution. Pulling this all together brings us to our final synthesis. Under the energetic paradigm, solving the ASI control problem means managing things across 5 specific layers simultaneously. Layer 1 is capability generation, governing how raw resources turn into stronger models. Layer 2 is abstraction generation, auditing how AI creates those new concepts we just talked about. Layer 3 is recursive improvement, strictly governing how the AI improves the tools that improves itself. Layer 4 is multi-agent coordination, managing how agent societies divide labor so there's no hidden drift. And Layer 5 is real-world actuation, controlling how the AI's answers actually translate into code, experiments, infrastructure, or physical real-world consequences. This entire setup relies heavily on a separation of powers. You have generators, verifiers, and memory auditors all operating independently to keep the flow network perfectly stable. Think about this quote for a second. ASI is not only a capability race, it is a control problem. We have these incredible mathematical North Stars, like Universal Artificial Intelligence, or AIXI, which show us the theoretical, absolute ceiling of intelligence. But a perfect AIXI system is practically incomputable. EOP, on the other hand, is the practical, everyday governance architecture to actually navigate that road. It acknowledges a hard truth. To keep scaling, recursive improvement, and real-world actions totally traceable, auditable, and safe as things get smarter, we literally have to govern the entire conversion process as one single energy flow system. This leap from AGI to ASI, it's not some distant sci-fi hypothetical anymore. It's beginning right now, wherever AI is writing code or accelerating research today. So the ultimate question we're left with is this. Will we let the future be built by raw, completely unbounded optimization machines, or will we step up and rigorously engineer governable intelligence? The path we choose right now is going to define the next era of civilization. Thank you so much for joining me for this explainer, and I highly encourage you to keep exploring these concepts on your own. See you next time.